Hi, folks. Welcome to another episode of Film Study. This is Ken McCusick. We have an interesting short for you today. Have a gentleman here who has done some research into pace of offensive play and is trying to work to create a expected pace metric. And he's Sam Hoppin. Sam, how you doing?
I'm doing well, Ken. Thanks for having me on the show. I think we chatted for the first time last year, so happy to be back.
Yeah, I appreciate always any new material of an analytic nature. We like to dig into methodology, kind of help people see what's out there. And your topic is very interesting for multiple reasons. But one is you've come up with an N factor model to look at expected pace. I want to let you kind of
Yeah,
talk through that, and then the Ravens' position in that is one of the reasons why I wanted to have you on the show.
sure. So most of my job in terms of data science revolves around the fantasy football betting space, and a lot of people in that context tend to use neutral script factors, whether it's neutral script pace, so seconds per play. I'll start there. When I say pace, I'm talking about seconds per play.
Mhm.
And one of my bigger gripes with any sort of neutral script filtering is that people use different definitions for neutral script. I tend to use like a 20 to 80% win probability window. Others will use the time left on the clock and the score differential. So there's just a lot of different measures or ways to come up with a neutral game script. And so what I wanted to do was to come up with an expected pace model to understand which teams are playing faster than they expected or slower than they expected. And with this, it accounts for things like the down, the time remaining, the score differential, all of these things. And if you have a team up 20 points in the fourth quarter, it still uses that data and captures that descriptive nature of the teams and how they're playing, as opposed to, again, some of these neutral script filters would cut that out. So what I
So let
did
me ask you a
was,
question there, Sam. So you're
yeah,
saying that you're not using a 20 to 80 filter in here. You try and include a play even when the team has a 2% chance to win, down 20 maybe in
yeah,
the fourth quarter. Okay, I
yep.
understand that.
And so what I did is I used the data from NFL Faster, which is the public play-by-play data, used data since 2015, since that's when they had the play clock data in there. So the amount of seconds remaining on the play clock when the ball was snapped. Used an XGBoost model to create an expected pace based on a number of factors. And I think you'll show here the different features that were included in this model, and ended up with an average error between actual pace and expected pace of 0.1 seconds. So pretty confident in saying that the model captures what sort of an average team would do in the given situation. And that's what a lot of these expected models, whether it's pass rate over expected or expected drop back rate, account for or are trying to capture, is what an average NFL team would do in those given situations. So you'll see here there are features like the number of seconds left in the half. Obviously, if there are less than 2 minutes left in the half, teams are going to play a little bit quicker, but that doesn't always necessarily mean that they're going to. The diff time ratio feature there is a ratio of score differential to the time left, so that captures a little bit of the, what if they're down by 20 in the second quarter, that's a little bit different than the time being
Got
down
it.
20 in the last 2 minutes. The previous yards gained, that's actually to capture stuff like, you get a 50-yard gain, it's going to take a little bit more time for the teams to actually get down to the field and snap the ball on the next play. And then you have down, score differential, and no huddle as well. So this is, again, purely a descriptive model. I plan to do more research this offseason on its predictive value, see if it can explain certain play calling tendencies, things like that. But yeah, the other big thing here is that it only considers, and it was only trained on plays in which the game clock was not stopped.
Got it.
So
So incomplete
basically,
pass would be a previous yards gained of 0, for example, but that play is excluded.
right, because again, in fantasy football and betting, we're looking for volume and which teams are essentially going to be playing, having more plays and moving the pace quickly. And so a team doesn't have necessarily incentive to play fast when the clock is stopped. In a 2-minute drill, they're not rushing up to the line when there's an incomplete pass the same way that they would if they had a 3-yard carry. So I think that's a big thing to capture as well in understanding how these teams play.
Let me stop you for a second. I got a question or two here. So the
Sure.
first thing I want to do is you come up with a 6-factor weighted model here, and you've labeled these out in a good way. The first one, I look at no huddle, and I'm immediately saying, is this really cheating? Because you're basing it on the fact that they're no huddle, which is kind of what you're trying to capture, I would think, by the model.
Yeah, and that's when I first came up with this, I came up with it about a year ago actually, and got some feedback on whether a no huddle play should or should not be include not that the play should be included, but whether that feature should be included.
Yeah.
I decided on using it because I think no huddle generally, and this is more anecdotal, but generally has the feeling that the team wants to play fast. They don't want to spend time in the huddle, calling the play. They just want to get up to the line quickly. I think it also helps with, again, some of that stuff in the 2-minute warning or when they're trailing quite a bit. So this is something I think I also want to revisit this offseason. I trained the model in the middle of last season, so we'll have a little bit more data this year, but it's certainly something that I think could or could not be included in it, and I'd be curious as to what the model would say without it.
Okay, here's my second question. That's interesting, and I certainly look forward to seeing more versions of this in the future, Sam. But um, when I see 7 factors like this laid out, my first question is, are you collecting overlapping information here, or did this go through, say, principal component analysis or something else that would reduce the amount of overlapping information you're getting from these factors?
Yeah, so I think there could be a little bit of that, and I think again with the way the XGBoost models work, it helps to, I think, eliminate some of that redundancy. Actually, gradually improving the situation, being able to layer on different parts of the puzzle. I mean, there are so many different types of situations in the NFL, right? Where being down 10 in the last, I'm not going to try to come up with 2 different situations, but there are so many different combinations of these different items where the model itself will distinguish what the most important factors are and how to weight them. Obviously, the x-axis here being the relative importance of each of these features. So I think there is, again, because I did it in the middle of the season last year, some more data, exploratory data analysis I could do on this. There are, I think, more stats that are being added to in the public atmosphere, if you will, in terms of what's available. So potentially using some of that as well, and then using those to build a different model.
Okay. Okay. And I don't want to dig too deep on this if you don't want to go into this,
Sure.
but I know you certainly know a lot more about things like principal component analysis from your background in data analytics. Is that something that's part of the XGBoost algorithm in terms of selecting features for you? Did XGBoost select the features for you, or did you tell it, I want to consider these 5, find me the best ones of those, or how exactly did you go about that process?
Yeah, good question. So this, I choose the features that I want to include in the model, and then it will, again, like I said, weight
Okay.
the features that I selected based on what it says. So it's not going to, I guess theoretically it could not include no huddle by giving it an importance of 0, but there were, I don't remember off the top of my head, but there were a couple of other features I had included, but the importance was next to nothing. So I just ended up removing them just to make it a more sparse model.
Okay. All right. Fair enough. And sparse is usually good for that. But in terms of um, how the information here overlaps, more data, more training is what you're basically saying is going to help you try to decide if is a problem yet.
Yeah, yeah. And I mean, we see too in the NFL there are shifts in how teams react to certain things as well. I mean,
Mhm.
you could. I don't know if this is something I'd consider doing because there's probably really a lot of noise in it, but having certain team tendencies as well, whether it's different play calling, things like that, whether the previous play was a pass or a run, things like that. So there there are a lot of ways to go about this.
Mhm. All right. Now we've seen certain teams that, in terms of tendencies, that seem to have that. The Patriots, for many years, were a team that loved to run up to the line of scrimmage quickly, freeze the opponent's defensive participants so they couldn't substitute, and then be able to run a play at their leisure, call out the line of scrimmage, and work off that. Um, are those the kind of team tendencies you'd be talking about that would be captured by another factor here?
Yeah, it might be more about like the given offensive play caller. I think the quarterback honestly drives a lot of this as well because they have their specific cadences and things that they look for pre-snap
Mhm.
that you can't necessarily account for in a model like this. Like we are talking before the show, I'm a Packers fan, and for the last decade we would get headaches with Aaron Rodgers running the play clock down to 0 seconds before snapping the ball. So again, that's sort of what I say when it's a bit of a descriptive model and just understanding how the Packers are playing and that level of play style. But some of that is again going to be quarterback play caller driven as well.
Okay, well, let's talk about some of the results as they pertain to the Ravens here, because I think this was one of the interesting things, and certainly for this audience, that they'll want to see.
Sure. So let me pull up here. So this here compares teams' expected pace. Let's get rid of this thing on the bottom here. Expected pace on the x-axis, and this is again in seconds per play, and then their actual pace in terms of seconds per play. And the axes here are reversed to show teams that have a higher, I guess, a faster expected pace and a faster actual pace on the top right. And the slightly darker black line in the middle, if you are above that, you're playing faster than expected. If you're below it, you're playing slower than expected. So you can see here, this is just looking at the last 4 weeks. I believe I have the full season as well here. The Ravens have the slowest expected pace of the season so far. And this is likely driven by the game scripts that they've been in all year, right? Like they're going into the fourth quarter leading
Every
most
week.
of, if not all of these games, right? And so by that nature, they're not expected to play fast because these, an average team is going to want to drain the clock out, things like that. So they're playing a little bit faster than expected. As you can see, they're just above that black line. But this is again like it's one thing to, and this is why I look at the expected pace versus the actual pace instead of just looking at the raw over or under expected pace numbers, because the Ravens might be slightly faster than expected, but that doesn't necessarily mean that they're moving faster than a team like the Giants or the Patriots that you see on the top right. So it's a lot of context that you need to put into this, right? And understanding how these teams are playing.
So I'm looking at this graph, and tell me that I have this right. It looks like the entire range of pace from the fastest to the slowest in terms of actual is less than 5 seconds per play. Guess
Yep.
that's not shocking out of 40 seconds. But in terms of expected pace, the total range is 2 seconds per play. It's very narrow banding that the model expects these plays to be run at in terms of pace.
Yeah. Yeah, and again, that's I think largely due to, again, we've got a much larger sample
Mm-hmm.
of plays that were used to train the data on, and I don't there are going to be very few game scripts, I guess, where a team is expected to play at, a 20-second per play clip versus a 40-second per play clip. And teams are good. Obviously, they have control over how fast they're playing as well. So, yeah, I mean, that's a good point. I guess I hadn't really thought of that too much, but I think it's something to consider looking into in terms of how variable these aspects are.
That I guess that's the question, and you might have just basically answered it. But should we be surprised that there is a 5-second difference in actual, but there's only a 2-second difference in expected? Are there good like data analysis reasons that I'm not thinking of through my foggy head right now that you would point to, that you see that in nature a lot or in other data?
Yeah, I think, and again, this is anecdotal, but you see a lot of the teams on the bottom left part of the charts are generally teams that have been playing well, that have been leading the games. It's the Eagles, the Niners, Jaguars, Ravens, Chiefs. So they're naturally going to be in more situations where they're leading, but it's the situations that they're in don't always necessarily get, I guess, captured by the model. So there's a little bit of nuance again too. Like some of the game script things do weave itself into this, or can't necessarily be captured by the model because of data, not data issues, but the data not being in there, or things like that. So I do think lost my train of thought here for a second, but there is a lot to consider here with, again, which teams we're looking at.
Okay, so if I were looking at this as an actuarial problem, the first thing I'd say is if your actuals were overstretched in terms of expected, I would be less confident in the model. I actually think a tighter range is probably good. If you have factors that are there's an example I give for baseball that I think is maybe worth the payoff given the minute it's going to take me to explain it. If you looked at 3 factors only for projecting home runs for players, is the guy the cleanup hitter? Is he the highest paid player on the team? And is he the first baseman, let's say? You'd have a lot of overlapping information you'd gain from that. So let's say each one of those said he was twice as likely to homer in any given at bat. And then you project that over at bat, say, you might find that you'd have 8 times as many expected homers where it'd be nowhere near that much because you have tons of overlapping information there.
Mm-hmm.
If I were to see something where the expected, literally ranged from 10 to 40 seconds, obviously that's an absurd a stretch on the thing, then I'd immediately know the model has double counted information that I'm feeding it in terms of generating the expected.
Yeah, and that certainly could be the case with the features I included that we talked about earlier. So definitely need to check into some multicollinearity there. I think the other part of it too is, I mean, with this and a lot of the stats that I put out, I'm really just looking at the extremes of things, right? Like looking at the teams that are very high up, over expected, or very, very far below the expected stuff, because those are the teams where I think things are generally going to have a more meaningful impact. But certainly giving me a lot to think about in improving and updating this model over the offseason.
If you're a Ravens fan, you look at this and you say, if you want to play the which of these ones is not like the other game, you want to be on the left-hand side of that chart big time.
Yeah.
And you don't want to be the Patriots, Cardinals, Jets, Commanders. Literally, these are the worst teams in the NFL. Panthers or Giants on the right-hand side of the chart, playing fast all the time. Yeah.
Right.
Makes it's confirmatory in a way, but I love what you've done here in terms of trying to put together an N factor model. And by the way, you're a data scientist, so you know this, but I consider no model is bad. It's all about taking that first step and being willing to do it, even if it's a misstep. I mean, just
Yeah.
let's talk about it. Let's see what this model tells us, and then create a better model the next time around. And honestly, this really passes the sniff test to me in terms of giving us very good information off the bat because of how it separates good and bad teams. It doesn't overstretch the expected interval that you could be going in. It's just it seems like it really fits together in terms of what you got. It's a very interesting new thing to look at in football. They don't come along every day. They come along now
Right.
about half the days on Twitter, but it's great
Right.
stuff.
Yeah. Well, thank you very much. I mean, I think the other part of this too is, again, this stuff highly correlates with some of the neutral script pace things that I mentioned earlier, right? Like it's not, I don't think, going to create any new groundbreaking analysis by any means, but it does, again, it's the context of being able to understand, okay, if a team has, again, a expected pace of 31 seconds, them playing at 31 seconds per play is not that outrageous. Like they're sort of doing what the game script or tendencies would expect in that situation. So just a matter of, again, not necessarily dinging for teams for being good enough to build those leads, because again, that's some of the balance with this fantasy football and betting analysis too, is some of the slower paced teams, like again, the Niners, the Bengals, I guess, with Joe Burrow, are very slow, but they're also extremely efficient. So they're scoring a ton, even though their pace might be a little deflated.
Yeah, it's fascinating stuff, Sam. Really appreciate having you on. You're welcome anytime, and I'd like you to send me anytime you create a new metric or have an idea like this. I'd like to make sure you send me that. But tell folks where they can talk football with you online.
Yeah, so you can find me on Twitter or X at Sam Hoppin, as you can see on the screen. I do a podcast every week on the Betting Pros podcast feed right over on fantasypros.com as well. So most of my most consolidated work will be over on Twitter, though, which is where you'll be able to see charts like this every week.
All right, great stuff. Other folks out there, if you'd like to be on a film study short, hit me up. Always available on Twitter. DMs are always open, and I'm looking for ideas just like this, but other ideas if you're a passionate Ravens fan of anything specific you'd like to talk about. Sam, thanks again for joining me,
Thanks, Ken.
and we'll talk to you next time on Film Study.